Guys, previously I mentioned the fact that we can use a Cisco device as a DHCP server in passing, but I was talking specifically about the fact that we can create or use a regular server for the purposes of issuing IP addresses using Dynamic Host Configuration Protocol. What we want to do right now is we want to delve a little bit deeper into the notion or the idea of using a Cisco networking device to be able to accomplish this particular goal. And first, what we want to do is we want to talk about why we need DHCP addresses. So what would be the recourse? Why would we deploy this particular solution in our infrastructure? And again, it's really going to boil down to the fact that we want to minimize the overall amount of configuration and administrative burden that we have on ourselves. Because issuing these addresses in medium-sized environments is time-consuming. We can make typographical errors, and also it's not going to support this concept of having our users be mobile inside of the infrastructure. I'm not talking about taking a laptop from one section to another. I'm talking about the fact that I need to move a PC from point A to point B. Then what I may find myself is in a different building on a different network segment. So we can run into issues that are going to be associated with these addresses if they're manually assigned. Now obviously, the primary way to get around this issue is going to be using DHCP assignment. And even though a Cisco router or a Cisco switch isn't built specifically for the capability of issuing these IP addresses, we do have the capacity of being able to implement it. And that's one of the things that we want to begin exploring. So as we go in and we start looking at DHCP as an option, what we need to understand is, first of all, the communication process that takes place. Now, there's a mnemonic that I recommend to all students that you use, and that's going to be DORA, like Dora the Explorer. Now what we're going to find here is DORA represents exactly what's happening in the exchange of information between a DHCP server and a DHCP client. Let me step out of the equation here and let's look at that. So first of all, the D stands for discover. We're going to send information via broadcast to our device. So this client is going to say, hey, I need a DHCP address. The O stands for an offer. The server is going to receive the broadcast and it's going to send the information or the IP address to the client in the form of an offer. The R is going to be the request. In other words, what's going to end up happening here is the system is going to say, yes, I want to use that address. And then what will happen is the final A here in DORA is going to be the acknowledgement that's going to be sent to the other computer. So this four-way communication process allows a DHCP server to, one, see the request for a dynamic address, and two, to satisfy that concern. And again, also, once it's issued it, we have this acknowledgement process. So DORA, discovery, offer, the request, and then the acknowledgement. So that means that now what we find is we find ourselves using this concept of DHCP to issue IP addresses. Now, we can configure DHCP to run on a number of components. We can configure it to run on routers. We can configure it to operate on switches. So what we're going to talk about is configuring a DHCP server to support LAN guest users. So in other words, in the concept here, let's say we have PCA and PCB. So we're looking at this, again, what we're going to do is first of all decide where we're going to make our configurations. We're going to configure DHCP on a router, so on this device right here. Now that means we're going to have to assign addresses from an address pool that we're going to define. We're going to say that address pool is going to be anything in the range of 10.1.50.0/24, and we're going to give it a lease time of 12 hours. Again, that's just a security oversight that we're going to put in place to make certain that these addresses aren't permanently issued, because again, we want them to rotate in our infrastructure. Again, a concept of kind of hardening our infrastructure and our network. Now, the other part of this is that what we're going to do is we're going to have to pick addresses that we don't want to assign. So we're going to have to exclude parameters and variables. So for instance, any address that is currently assigned to, say, for instance, a router or a switches management interface, what we're going to do is we're going to make certain that the DHCP server doesn't issue those addresses so that we don't run into having redundant or duplicate IP addresses on our infrastructure. So, I mean, from a 30,000-foot view, it's a pretty simple process that allows us to make the implementation. And we really want to focus on exactly how it's done. So like I said, first of all, we need to configure a few elements. The first thing that I want to do, and what I always do first, is I configure my excluded addresses range. So the addresses that I'm not going to issue. The reason I do that is this is issued at the global configuration. Everything else is going to be entered in the IP DHCP pool. So if I were to set up this portion first and leave the excluded addresses off, the reason that I do this first is because if that were the case and I left it off, I could accidentally issue one of these addresses in the interim that it takes me to get this far into my creation. So I'm going to define my pool. I'm going to give my pool a name, guests. I'm going to assign the network that I want to issue the addresses, and this is going to be one of the few times we'll find ourselves having the capacity to use the / or cider notation. Now also what we're going to find here is I can issue my default router. So that's going to be the identity of the default gateway. Typically it's the DHCP server itself, but it doesn't necessarily have to be. The other thing is I'm going to issue any DNS servers that I have deployed. One of the primary reasons or the benefits of using DHCP in Cisco's deployment is that I can issue primary and secondary DNS servers so that I have the capability of having my primary and my secondary zone lookups. Now the other part of this is that I'm going to issue my domain name and my lease. My lease is going to define, in this instance, 12 hours that we're going to use to ensure that that's going to be how long an IP address is going to be issued. And when the lease expires, it's going to be forced to refresh the DHCP address that it's learned. Now, the other part of this is that we need to understand the fact that we're going to want to make certain that we can monitor this process. So how do we know that it's actually working the way we want it to? Well, the key command that we use here is going to be the show IP DHCP pool. The show IP DHCP pool is going to give me the issue or the variables that are operating in my environment. Notice here it tells me my total addresses that are gone. How many addresses have been leased out? Are there any issues? So for instance, one subnet is currently in the pool and how it's been arranged, and also it repeats the information here. Actually, let me remove myself from the equation here. So the show IP DHCP pool is one of the ways that we can actually verify or monitor that things are operating. Now, the other part here is that if I want to do further monitoring, I can find out what IP addresses have been issued. So what we're going to find is we're going to have a MAC address, and we're going to bind IP addresses to it. So we can look at this database of information by doing the show IP DHCP binding, and it's going to give me my IP address, in this instance IPv4, and it's also going to give me my hardware address that I'm using in this configuration. Now, it's not necessarily a MAC in Cisco. In Cisco, it's going to be this hardware address, or what's referred to as a client ID. So it's not going to be the actual MAC, but the point here is that I know which device has been issued what IP addresses, and I can review it by checking the contents of the show IP DHCP bindings command. Now, further monitoring is going to extend to the capacity of being able to determine whether or not I get actual IP addresses issued. Now, one of the things that we want to make certain here is that, again, we don't have duplicate addresses in our infrastructure. And what we have to realize here is that our devices are going to resolve conflicts. So notice right here we have the show IP DHCP conflict, and it's going to give us any information associated to the nature or the behavior of our infrastructure with regard to what's happening. So it's going to display address conflicts that have been found by a DHCP server. It's going to list the IP address. So it's going to be the IP address of the host as recorded by the DHCP server. How is it going to do this? Well, what it's going to do is it's going to use a series of pings or gratuitous ARPs in order to be able to resolve identity. And what's going to end up happening here is it's going to be following this idea of the detection time, which defines the time the conflict was found. Now, the conflict may resolve itself. It could be resolved by a reboot. A lot of times I find this actually happening when I'm using a router for a DHCP server, and I don't actually save my binding database or store it in flash. And when I have to reboot the router, what ends up happening is it comes up fresh, and some of the devices still have their lease from the initial issue, and then ultimately in the situation it will actually resolve itself. But there are circumstances and situations in that particular condition where we can actually have duplicate IP addresses existing on the devices because it's actually been issued more than one time. Now the other part of this is that we also need to recognize the fact that in our original scenario, I was talking about DHCP, and we had two routers that were actually connected to each other. Well, one of the things that we may find is that we might find ourselves in a situation where we are going to have to recognize the fact that we can actually support a concept called centralized DHCP. The reason that we would do this is that managing individual DHCP servers across large distributed locations is going to be very, very time consuming and something that we're not necessarily want to expend a lot of resources doing. Also bear in mind, the more DHCP servers that we have, the more effort we have to put into ensuring that we have consistency in our configuration. Again, making certain that we don't have replication of addresses or issuing IP addresses to multiple devices, especially if we have different DHCP servers issuing addresses in the same ranges. Now, when we look at how this is going to be deployed, the idea of a relay agent, so the only DHCP relay agent needs to be configured. So in other words, it's going to be a router in our infrastructure that knows how to get to the centralized repository of DHCP services. And the way that we're going to look at this is that we're going to enable a DHCP agent on the device, and the device is actually going to act as a middleman at this point. So it's going to receive the broadcast from our host, and then what it's going to do is it's actually going to forward that broadcast onto another Ethernet segment. Then it'll take the offer and refer it, and actually what we're going to see is all of these communications following the idea of DORA still repeat. And the only thing that's required to make this router act as a IP helper or a DHCP relay is to issue the command IP helper-address and give it the identity of the DHCP server. So now what's going to happen is this device, this router is going to take this information, it's going to re-originate it, and it's going to send it on. And this is going to be a situation where I could have multiple routers in my infrastructure, and what I can do is I can set one up as a relay agent to send information all the way to the server. So again, it gives me the capability of being able to extend my DHCP environment, and at the same time it gives me the opportunity of being able to centralize my DHCP server in such a fashion that I'm going to minimize administration and configuration and downtime. That's going to wrap up our conversations about how we can use DHCP servers to act as, routers to act as DHCP servers, or more specifically Cisco devices, because we can also do it on switches. And as you can see, the configuration isn't that difficult. We just define the pool, and then we issue the range of addresses, making certain that we normally would exclude the addresses that we don't want to be issued first because it's done in a global configuration, and then we simply turn the system up and allow things to operate. So with that being said, I'm going to conclude this particular lesson, and I'll see you on the next one. Bye-bye.